Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about space economy of 2025. So let's dive deep into it. So we are talking about some serious money here. Now it is expensive. Space is expensive, like really freaking expensive. As of now, there is nothing that even comes close to this, including silicon industry. The amount of money these things consume is like, it makes everything else look like, bro, chump change. Now, how can you get into this? Well, there are only two ways to getting into it. First, you need a whole nation, basically a whole nation's tax base to get you into it, or you need to have ludicrously deep pocket. For example, Jeff Bezos or Elon Musk. So these are the reality here. Basically, can you try it? Of course you can try it, but can you actually succeed? Yeah, that requires a very deep pocket. So that's one of those things. So as of now, how many companies actually exist that's like, okay, we are a thing, we are launching rockets, our rockets are actually going to orbit? Yeah, the list is very small, surprisingly small, given the fact that how many companies are registered as space companies. So that's one of those things that you're like, whoa, that I thought the number would be this much, it's like this much. Then you figure out how many are cash positive, as in like we built something, we R&D'd on it, we launched the service, now we are making a revenue out of it. Yeah, almost nothing, not even this, like flat out not. And so it's one of those things that you have to understand. And the reason why you need very deep pocket is simply because it's a very slow burn process, meaning you can start a company with, let's say, electron rocket, but the moment you start, you will trigger a death clock. Basically, it starts to run downwards, and before it hits zero, you have to make sure you have even bigger, better rocket ready. For example, neutron. So that's the whole point. It's a slow burn. That's why you really need very deep pocket. So let's understand the early starting of it. So that all started because of this puppy, V2. So space became the final frontier at this point in time. And this was the easiest way for super powerful nations to show mines are bigger than yours. Mine is bigger than yours. So flat out, people poured money like there is no tomorrow. Like common people do not generally have a context how much money NASA consumes from national budget. Here's the answer. It's less than 0.5%. Not even 1%. Like it would be a good day if they get 0.75%. Generally, they do not even reach that. Generally, it's 0.5 to 0.45, and you can write down a year by year list below if you need to. But when this was happening, basically when they wanted to show mines bigger than yours, they were burning upwards of 4%. Like that's bonkers amount of money that was just like, go YOLO on it. So that's why these things were built. Can Russia build something like this? Physically, yes. Can they afford it? Hell no. Can America build like this? Yes. Can they afford it? Hell no. So that's the whole point. These were the only two superpower remaining after the world wars. So USSR and USA. So, and be mindful, UK did had enough intelligence that they did try to build it, and so did France, but they suffered catastrophic destruction from the world wars. So they were not really like, actually had the horsepower to do it and money to do it. And be mindful, UK is a really tragic case because they did had a company as in like a basically group of people who were actually building rockets for a nation. They were like actually good, like not joking, they were actually good. And politics went poof onto that. And right now, as of now, as in like let's say after 2010, China, Russia, India, European Union, these are the new players. Soviet Union went poof, USA is still a superpower. So right now, the new champions are China, let's say bye-bye to Russia, India, and European Union. So this is the early beginnings of it. Now, once that beginning happened, we reached into commercial era. Now, commercial era is when people actually started to think about, okay, we're spending money, that's good. How do we get that money back? So this happened just after Cold War ended. Basically, Cold War went hot. Cold War basically fizzled out. At that point in time, market forces took over because, again, NASA was not going to get the money that they were getting in the Cold War, and most research project was like, poof, gone out. So flat out, they really needed to look into commercial sector. And commercial started is the first thing that actually started to pay for space survey, meaning I'm going to pay you to put my satellite up there. Not just a government project, I'm going to pay you for this. So this started. Now government also started to do this because they wanted to really spy into that. So they wanted to make sure they look into that. It's like, no, yours is smaller than mine's. And then meteorology. Now you may find it odd. It's like, why government is spending on meteorology? Well, here's the deal. Majority of government's job is taking care of people. That requires to know the disasters. Majority of disasters could be understood if you understand the weather, be it a drought, be it flooding, be it tsunamis, things of that nature. So basically basically, if you understand the weather, it actually allows you to control your nation much better. Basically, it allows you to navigate hazards wisely. So from a government point of view, it's actually wise investment to understand the weather. So that they really invest into that. Then we have the biggest money maker early stages of actually commercial system. It's TV broadcasting. The moment we figured this out, that it's a thing, it can be done, and we can have what we call worldwide TV or global broadcast, money started to pour in. As in, like, the money that went into this sector at that point in time for geostationary satellite keeping, it was like, whoa, like serious amounts of money was spent into that. It changed the game. And then communication also happened, but communication was not that big. It was there, but not like, whoa. But TV broadcasting, it went bonkers. After that, after all of these things happened, some bad events happened, including a plane going poof because it deviated into an enemy nation and they fired missile into it. Commercial plane. So yeah, bad things happened. So satellite navigation was opened. At that point in time, GPS was decided to be made for public. Now, what does GPS made for public means? GPS was a thing. It was built for missile guidance. It was a done thing. But here's the deal. GPS, you cannot decode it unless government itself removes the encryption out of it. So they created a two ecosystem out of it. First is military ecosystem, which is like complete, basically absolute precision, meaning it says it's here, it means it's here. That's how missiles are guided. But there is a sloppier version that is available for commercial use, which you're like, you are in this area. That's why, like, your normal GPS does not tell you which road you are in. Basically, if you have a military GPS, it's gonna tell like, bro, you are in this lane, exact lane. If you are a 6-lane road, it's gonna like, no, you are exactly here. This is exactly where the center is. Now, again, this also created many issues. For example, during India in Pakistan war, USA kind of acted as a mediator, and at that point in time, Indian Air Force was relying on military variant of US GPS. USA turned that encryption off. Now, how they did that, that's up to them, but they did it. And that pissed off India so badly that India is like, okay, we're gonna learn from this and we're gonna launch our own satellite navigation system known as Navik. So it changed the game. Not only from a boom sense, it also changed commercial industry. You think about how big Amazon is solely because of this. Without this sort of navigation system, you could not just have, oh, I'm going to hire thousands of people and they're going to deliver things for me. That could not have been done because everybody who used to do delivery before this, basically in the post-man era, they used to know the area. Only then they can actually go somewhere and actually do it and do it efficiently. So from that to like, every Tom, Dick and Harry can do it, this job, basic level job, became possible because of satellite navigation. The amount of commerce, the amount of flights, the amount of things that was done because of this satellite navigation skyrocketed. So it was a game changer. And it directly led to creation of multiple global networks. For example, GPS, Global Positioning System. You have GLONASS, Russian system. Then you have Galileo, European system. Bindu, that is a Chinese system. Now, I'm not considering two ecosystem into this. That is Japanese and Indian, because both of them are regional as of now. Indian system will become GPS, basically global, but it is going to take some few more launches at this point in time. So this is the commercial sector, when people actually started to milk space and actually started to get money back rather than just like burn money. So this is after like, no, mine is bigger than yours, now what? So this is the second phase. But now we are reaching the final boring phase of it, that is saturation, meaning there was a lot of money to be made. In early days, there was a lot of money to be made in like commercial contracts, launching satellites, all that jazz. Now, once somebody actually starts to make money, it creates competition. More money, it attracts more competition. More competition leads to price competitiveness. Now, the moment you have price competition, meaning you're going to launch in 5 million, I'm going to launch in 4 million. Somebody else will say, I'm going to launch in 3 million. So price competition happens. What is the consequence of that? If you have too much price competition, it reduces what we classify as profit margin. Your input and output might be the same, but the amount of money you are gaining per launch may shrink so much. It's like, dude, if I had kept this money in a bank, I still would have gotten more money out of it. So profit margin shrinks, which leads to bankruptcy. So many company came and many company went simply because of this. Too much competition. And market has only so much size. Yes, you can launch satellite much cheaper than, compared to last 60 years. That's factually true. But here's the deal. Do you really need a satellite? Like, think about it. Like, do you really need a satellite? Like, think about it. It's like from a Tom, Dick and Harry point of view, it's like, do you really need to launch a satellite? Like we have satellite TV that is covered. We have optical fiber network, which is growing at exponential rate, and that has idiotically high throughput. And for many things, we could use either weather balloons or basically aircrafts with lidars to get a much higher resolution remote sensing than any satellite could do. So it reached a point where it's like there is a limited amount of capital. Yes, old satellites will be retired and new will be placed there. So there is a ongoing demand, but the pie is not huge. You would think like it's a hundreds of trillion dollar. No, 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 no. It's only few $billion per year, so to say. So the pie is very small. And consequence of that is like it creates oversupply, meaning, yeah, I'm also making a rocket, I'm also making a rocket, I'm somehow creating a steam rocket that somehow funders are funding. And then what happens after that? Bankruptcy. So you can have like, I'm going to have a small satellite launch vehicle, I'm going to have a small satellite launch vehicle, I'm going to have a small satellite launch vehicle. All you're going to have is bankruptcy, and it's already happened. So this is the consequence of saturation. Now, physics is very clear here. Bigger is better, flat out. Tiny rockets are not good. Bigger the rocket, the better it becomes. Engineering helps you to actually achieve more because your fuel volume to mass volume, basically dead mass, not the payload, the mass of the rocket itself, the proportion changes. Meaning if you are making a small rocket, how much percentage of propellant you have versus how much rocket you have, it's not that efficient. But the moment you increase the diameter, of course, your mass increases. Now you have a thicker wall, but you have larger diameter. The volume grows exponentially. Surface area will grow by square, volume will grow by cube. So benefit is bigger rockets are far more wise. Now that's all fine and good. That's science, that's absolute. That's the reason why Electron rocket company went from like, I started to make Electron, trying to recover it, and it's like, okay, let's work our ass off on Neutron. It makes sense. Same reason why SpaceX went from Falcon 1 to Falcon 5, and while they were designing Falcon 5, it's like, yeah, let's just use Falcon 5 and jump into Falcon 9. So that's awesome. That's factual. That's true. Who is paying for it? That's the painful part. Who is paying for it now? Because it has reached saturation. So what we can expect in the future? Well, this is the part where we have to understand now a company that has to survive in this for long duration has to actually create its own way of monetization, where it's like, no, I'm creating a rocket. It's like, oh, who you gonna provide launch service? No, 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 that's already taken care of. Then why? I have this reason to do it. Like they have to create their own monetization avenue by themselves, where it's like, oh, I'm gonna launch this is gonna do this, and that's how I'm gonna make money. It has to be completely enclosed system at this point in time. So what are the options? Well, the biggest option is space tourism, and I'm talking about going in orbit, not going dappa. I'm not talking about that. I'm talking about going and staying at least 1 or 2 orbits. So that is very untapped. Now you're like, why it is untapped? If we have a rocket, like SpaceX has a rocket, it has a manned capsule that is NASA rated and has successfully carried and brought people down safely. That part is sorted. So what's the problem? Well, problem is there is no destination in space. Like you cannot just ask to Chinese people, it's like, hey, can I use your space station? Nah, you cannot just, Russia, if they had it, right now there is none. So back in the Mir station days, like you cannot just like, hey, can I come up? You can't do that. You cannot just do that to ISS. So that creates a scenario. There is no destination. You have a vehicle to go there, but there is no destination. There is no Disney park there. So they are building it. For example, Axiom Space. If Axiom Space works out, only then SpaceX will finally have really good positive cash flow. If Axiom defaults or like does not get the yield result needed, yeah, poof. And you can look at the same thing in Blue Origin. Why they are focusing so much before even they have a full-fledged rocket? Why they are focusing on a space station? The reason is same. Unless you have private hotels in space that you control, you have nothing. Yeah, just, oh, I have a rocket. Like, who is buying from you? NASA is not getting the money that it used to. So it's like, who is buying from you? Like, oh, I'm building Starship for moon landing. It's like, who is paying for it? Yeah, NASA is paying half of it, and then they're going to use it 1 or 2 times. Yeah, you're going to go bankrupt if you do that. So that creates a very serious paradox. Basically, then who is funding this? Well, SpaceX. Why they are funding it? They are hoping that they're going to launch bigger variants of Starlink. Basically, why this puppy is built? For Starlink. That is their own circular economy. We're going to make a rocket, we're going to make big ass rocket, we're going to launch big ass satellites, and then we're going to provide badass satellite service. Then we're going to make money from that satellite service. Completely enclosed ecosystem. Now that's all well and good. And right now you must be seeing way too many companies are like, we're going to give satellite to mobile phone communication. Awesome, GG. But here's the deal. There is certain limitation. Laws of physics kind of limitation is that you need too many satellites to do this effectively. That's the pain point one. That's why this is getting funded, because launching it like, few at a time is not good enough. Flat out, like Falcon 9 is not good enough. You need this. So that should give you some context of launches, what kind of launch cadence you are talking about, what kind of oomph you need. Then it comes to the bitter aspect. Like I can put my money, basically, I can put my money on space tourism, but I cannot put my money on satellite communication, be it Starlink, be it any other brand, simply because there's not enough users. Like, wait a minute, we have the whole planet. Here's the deal. How much you gonna charge basically African nations, South Africa, let's just say? Not much. How much you gonna charge in India? Not much. And be mindful, in case of India, let's say the world's largest open market, we have surprisingly good fiber connection, and you cannot even come close to fiber that I have right now. My fiber is 3.2 terabytes of bandwidth, and at speeds of 300 Mbps up, 300 Mbps down. Downtime almost zero. Like the downtime I have is like, because the router is crappy, I have to restart the router every once a week. So it's the 5 gigahertz connection actually still works, because for some reason it reaches a point where it's like can't connect. So compare that, and if I told you how much I am paying for it, most of you will hate me. So that's the reality of it. It's flat out not competitive in India. Yes, there are some remote places that has nothing, but all of them are also getting fibers. And if you actually start to see, people are buying, let's say, Starlinks, and actually pressing. All national companies that are like in a nation, they have the technology to go there. They are just like lazy. Like USA was giving boatload of money to all its fiber providers. It's like, hey, lay down the fiber. Once you have the customers, you're gonna make but we're gonna take care of the capital, so you can take care of the running cost, and you have provide basically connection to these remote places. They poured money like there is no tomorrow. The amount of money they poured, even if there was only 70% of it being used, it would have covered 100% of USA. 100%, meaning most people would have been 10-20 kilometers away at max from a fiber point. They are not. So what does that mean? That means free reign for this? Well, yes and no. Yes, because that's how it's working. No, because that means it will take some companies to like, what if we actually lay the fiber rather than losing customer? Then it's like, poof, game over. Now, there are some customers, like for example, any customer that is mobile, as in moving, like aircrafts, boats, those things will like shut up, take money. Military, shut up, take money. But are there really enough of them? It's the same thing like Rolls-Royce is awesome. It's like, no, it's been sold to BMW. That should tell you everything you need to know. Like you want to be Honda or Toyota, you do not want to be Lamborghini. So that's why future is only based on the people basically who are like, I'm actually gonna do something. So right now, do something is space tourism. Satellite communication, in terms of input and output of money, tough. But I will put my money on basically space tourism. Other things, not so much. But again, that's my option, and let's see what happens in the future. But be mindful, majority of the companies that are coming in, they're gonna go poof very soon. So this was my presentation on basically the economics of upcoming years of space. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.